Hello, everybody. Okay, today we're going to figure out how much weight we can put in our buoy. And as engineers, we make assumptions. And one of the assumptions we made is that we think that a piece of 4-inch PVC might work. And so we have really at this juncture no idea whether that'll work or not, but we're going to make that assumption. We're going to further assume that it's going to stick out of water 3 feet and be submerged 7 feet. All right, so let's get started. So one of the things that you want to learn, one of the tools you want to put in your toolbox is spreadsheets. All right, and this is like a hammer to a carpenter. You know, a carpenter can drive nails with a 2x4. He can drive nails with a brick. He can drive nails with a stone. But a carpenter who has a hammer is a lot more efficient than one who doesn't. Same as engineers. Engineers who have a nice mastery of spreadsheets are going to be way more efficient than engineers who don't. So let's get started. All right. So remember, a gentleman by the name of Archimedes in the 13th century said that the buoyancy, the force that something floats in water, is equal to the weight of that water that it displaced. All right, so we're going to have to figure out the weight of the water that a piece of 7 foot a piece of PVC displaces. All right, so let me talk just briefly about spreadsheets. Here's a very helpful way for me. It helps me present to people my thinking and how I got there. So in the first column I put the variables, and it's really important to put the units. All right. The units make you think and help you look at the values you get. The next thing is that these variables have some values. I just put them in here. I'm going to do some calculations. I typically make this column yellow, and then I write out the formula. And I do it in a rather verbose mode. So let's get started. We need to know something about pipe. All right. So it turns out that I just know that an outfit called Magmastic Car, here's its URL, sells pipe, right? So I type in 4-inch PVC. Here comes a nice chart on 4-inch PVC. Notice it gives me the inside diameter, the outside diameter. It gives it inches, and it turns out that I want to keep my units consistent, and I've chosen feet as my units. That's why it's important over here to remember to put the units. All right, so watch this. So my chart gave the diameter. I know that the radius is half of the diameter, so I put equal 4.5 divided by 2 divided by 12. This gives me the radius in feet. All right. It also has the inside diameter is this. It's 4.03 inches divided by 2 divided by 12. That's equal to it. We assume that we wanted 10 feet of pipe. I put that in here. We assume that we're going to let 7 feet get in there. Now the density of water. What is the density? And the density of seawater, incidentally. All right. So I go over here to Google, type in density of water, here, or density of something. Here comes a nice little chart. Look at here. Seawater, it's in the units I want. All right. And also, while I'm here, I'm going to need to know this, and I'll tell you why in the next explanation. So, all right, and I paste this into my spreadsheet. So anybody knows where I want it, where I got it. Here's where I got it. All right, now I come back over here. All right, now I'm looking for specific gravity. I'm looking for the density of PVC. So I go in and I Google that, and I get all kind of numbers, a humbug. Basically in the metric units, I don't like to think in metric units, but I find something called specific gravity of PVC. What is specific gravity? Specific gravity is the density of an object relative to water. So what this tells me is that PVC weighs somewhere between 1.35 and 1.45 times its weight in water. Right? Engineers want to design initially going in on the worst case. We're going to take this number 1.45. Right? So I come over here and I put 1.45. Now I want to find the density of PVC. What is the density? Well, it's the specific gravity times the weight of water. All right, so watch this. Come over here and put equal. So the specific gravity times the weight of water, not seawater, just plain water, right? Look at here. Here it is. It's 90 pounds per foot cubed, all right? Now, I want to get to the weight of the water displaced, all right? So the first thing I got to do is find the volume, right? And the water displaced, remember this thing sits in 7 feet of the water, all right? So what is its formula? Well, it is, and I wrote it out here, but I'm going to talk about it. I hit the equal sign. It's 3.14 times, right, the radius, okay, and radius squared, right, times the length. What is the length? It's 7 feet in the water. There it is. Neat. Look how easy this is, right? And you can go over here and look at the formula, and you can click on this little thing, and it tells you the variables that you use. In other words, so I'm going to clear that to keep going. All right, now, what is the weight of that water displaced? Well, it's equal to its volume, which is this, times its specific, times its density, which is 64 pounds per cubic foot. Look in there. That pipe, 7 feet of pipe, PVC, will displace 49 pounds of water. All right. Okay, now we got to find out the weight of the pipe. All right. So the way we're going to do that is we're going to take the volume, the outside volume, subtract the inside volume, multiply it times its density. So watch. We're going to do this in steps. So now the outside volume of the total pipe is equal to 3.14 times the outside radius squared times the length of the total pipe. All right? And that is 1.1 cubic feet. All right? Now let's take the inside diameter. It's okay, it's its formula. It's equal to pi 3.14 times the inside diameter, whoops, squared times the length of the total pipe. Okay. Now, the volume of the pipe is let's figure out the formula. It's the outside volume, which is that, minus the inside volume, which is that. All right. So that volume of that pipe is now this. All right? Now, what is its weight? All right. Its weight is equal to its volume, that, times its density. All right. And its density is right here. All right. So that pipe weighs 20 pounds, roughly. All right. So what is the buoyancy equal to? Well, the buoyancy is equal to the force pushing up, okay, which is this, minus the weight of the pipe, which is that. Okay. Look at here. All right. Here's the answer. That buoyancy, that force pushing up, is about 30 pounds. Does that make sense? I think it does. If you think about a noodle in a swimming pool, you know, you can float on it. It's pushing up, and it's pushing up with a pretty good force. All right. So I think this thing makes the sanity check. All right, guys. Till next time. See you later.